All right, 1-5, simplifying algebraic expressions, which I think will be on 26. A couple things we need to go over is a term, the word term, okay? And I'm going to show you this definition through the use of a picture, or an expression. So 2x plus 5y, okay? Each one of these is a term, okay? So this is a term, and this is a term. This expression has two terms, okay? The coefficient is the number before the term. So this 2 here, this is the coefficient. All right? And then this here, obviously you should know, is the variable. All right? So, we are going to be talking about like terms today. So, I'm going to give you some examples of like terms. Like terms. Okay, here are some examples of like terms. 3x and 2x, 5y squared and 2y squared, 5 and, can't write, 1.8. Okay, like terms. They are like terms because they have the same variable and exponents. Okay? The coefficients can be different. So coefficients can be different. And I think you'll notice that in those examples where 3x and 2x are like terms because they both just have an x, but they have different coefficients. 5y squared and 2y squared are because they both have a y and a square, but different coefficients, okay? So the first thing we're going to do is there is a list of terms. We have 5a, we have t over 2, we have 3y squared, we have 7t, we have x squared, we have 4z, we have k, we have 4.5y, we have, squared, sorry, we have 2t, and we have 2/3 a. Okay, what we're going to go through and do is we're going to figure out which terms are alike, okay? So, I'm going to put a box around 5a, okay? And then any other term that has an a with no exponent is going to get a box. So, here we go. There's a term with an a and there's no exponent. The coefficients are different, but that is okay. Now, I am going to look at another one, and we're going to put a circle around the 3y squared, okay? So if I put a circle around the 3y squared, I'm going to put a circle around any other term that has a y squared, and it looks like this one has a y squared. Now I'm going to look at the t divided by 2. And I'm going to look at any other variable that only has a t with no exponent. This one here, and this one here. Okay? Now I'm done. These three terms aren't alike with anything else, so we're not going to box them up. Okay? So, you can combine like terms. All right, so if we were looking at this and we said we have a 3y squared and we have positive 4.5y squared, what we do is we add the coefficient, 3 plus 4.5, and get 7.5, and then our y squared stays the same. So we add coefficient, in this case. If there was a subtraction sign, we would subtract. Okay, so you have to follow the signs. Variable and exponent. And that is the hardest thing for kids to get, is that you don't change anything about the variable and the exponent. Okay? So, let's look at a few problems on page 27. I'll try to not make this video super long, but it might be a little longer than 10 minutes today. 2a. We have 7x plus 2x. First thing I'm going to do is I'm going to signify my like terms. So I'm going to put a box around the 7x. And the other term, 2x, has an x with no exponent as well. So I'm going to put a box around that. And then, so I identified like terms. And now I'm going to follow the operation for those like terms. Notice how I put the plus sign in my 2x box, because that tells me what I need to do with the 7x and 2x, and that makes problems that are a little longer a little bit easier. Okay, so 7 plus 2 is 9, and I leave the x the same, and this is my answer. So for here, we added the coefficients. Okay. So our next problem is a little bit bigger, so it might be a little bit trickier, but hopefully we can get through this. 5x cubed, that's a little 3, plus 3y, plus 7x cubed, minus 2y, minus 4x squared. Okay, so we're going to follow the same steps. We're going to identify like terms. So I'm going to put a box around 5x cubed, and then I'm going to look for any other term that has an x and a 3. The 7x to the third does, and I'm going to box the plus in front of it. Okay, now I'm not going to box the last term, 4x squared, because even though they both have an x, one has an exponent of 3 and one has an exponent of 2. Now I'm going to look to positive 3y. Circle the sign in front of it. Now I'm going to look, are there any other terms that just have a y with no exponent? This one does. Okay? So this negative 4x squared is just out here by itself. All right? Doesn't have anything alike. So now what we're going to do is we are going to put our boxes together. Okay? So we have in a box 5x cubed plus 7x cubed, and I'm going to box that into one box. Then we're going to take plus 3y minus 2y, and I'm going to put that all together in a circle, and then I'm going to have minus 4x squared. So now I'm going to follow the signs. So in this first box, I'm going to add my coefficients. 5 plus 7 is 12x cubed. Then in my circle, I have 3y minus 2y. 3 minus 2 is positive 1. And then I don't have anything to combine with my last term, so I just bring it down, negative 4x squared. This is my answer. You cannot combine your boxes and your circles and your non-shaped stuff. So there is no further work to do for that. You're done. Okay, let's look at one more. This one's really pretty difficult. I'm surprised they have it because I don't feel like we've talked about the distributive property, but apparently we have. So let's look at this one. 2c. Okay, we have 2 times a plus 2a squared plus 2b. Okay, with distributive property, you are multiplying this outside term by each inside term. So I'm going to multiply the 2 by the a, and then I'm going to multiply the 2 by the a squared. Okay, so what that looks like is I have 2 times a, bring down my plus sign, 2 times 2a squared plus 2b. Now I need to multiply 2 times a, and when you multiply 2 times a variable, it's just 2a, okay? Plus, now I have to multiply 2 times 2, and I get 4a squared plus 2b, okay? So, looking at this, is there any other terms that just have an a with no exponent? No. Are there any other terms that have an a with an exponent of 2? No. Are there any terms that have a variable of b? No. So this right here is my answer. Okay? Let's look at distributive property for a minute. Let's do 3 times b minus 5. Okay? So I have to multiply my 3 times b, and I have to multiply my 3 times negative 5. Alright, so I'm going to take 3 and in parentheses put b, bring down my minus sign, and then take 3 times 5. 3 times b is 3b minus 3 times 5, which is 15. We may talk about that later, hopefully, or we may just take a day and talk about it because that's important for you to know how to do. So at this point, if you're like, I got this, piece of cake, you can go ahead and do your lesson. If not, we're going to do a few more examples. Okay, so here we go. First one we're going to do is an easy one. 6t minus 4t. Okay, box your like terms. That has just a t, no exponent. And this has a t, no exponent. So we identified like terms. So I'm just going to put identify. And then we follow the operation, which is minus. 6 minus 4 is 2. And we do nothing to the variable. Let's look at another one. 3a squared plus 5b plus 11b squared minus 4b, where am I? Plus 2a squared, this is a long one, minus 6. Man. Okay, so we're going to start off with a squared. 3a squared, we're going to put a box around it. Now we're going to go through, are there any other terms with an a and a squared? Right here. Don't forget to box the sign. Now we're going to look at the b. So, I'm going to circle 5b. Are there any other terms with 5b? Or a b, I'm sorry, not 5b. Right there. Now I'm going to look at positive 11b squared, nothing else. And positive 6 has nothing else. Okay, so now I'm going to put my like terms together in boxes. 3a squared plus 2a squared. Put that in a box. And then I have positive 5b minus 4b. Put that in a circle. You can put it in a box too. And then I'm going to take my underlined ones, which means they have nothing in common with anything, and I'm just going to add them at the end. Okay, if they're not in a box, nothing happens to them. If they are in a box or a circle, the only thing that happens to them is they get added to or subtracted from whatever else is in the box. So 3 plus 2 is 5. We leave the a squared. 5 minus 4 is positive 1. We leave the b. And then we have plus 11b squared minus 6 that we just bring right on down. And we are done. All right. Okay, one more. Then I might have to stop. Three x plus 2, 2x plus 3, and just x. Okay? And they want us to find the perimeter. So, when we're finding the perimeter of stuff, all we're doing is adding up all of the sides together, okay? So, we're going to start by writing out an expression full of terms. So we have 2x plus 3, write that down. Then we're going to add to that 3x plus 2. Then we're going to add x. Okay? So then I'm going to follow the same rules. I'm going to go through and identify all my like terms. 2x, positive 3x, positive x. Okay? Now I'm going to identify my other like terms. Plus 3 and plus 2. And remember, those are like terms because they're just whole numbers and they don't have a variable with them. So now I'm going to go box my like terms. 2x plus 3x plus x. Put those in a box. And then plus 3 plus 2. And I'm going to put those in a circle. X equals 1x, okay? So when you're adding these, you're going to do 2 plus 3 plus 1, and you're going to get 6x. And then 3 plus 2 is positive 5. And there we have it. I think that's long enough. If you have questions, come and ask me.